reduce the following partitioned matrix to row-echelon form. Let's start by copying the matrix down. Now our goal is to get zeros in strategic places. For example, using this leading 1, we would like to get zeros in all of the entries underneath it by taking the first row, scaling it by different values, and adding it to the other rows. For example, if we scaled the first row by a -2 and added it to the second row, we'd obtain a 0 in the first entry. The first row scaled by a -2 is -2, -6, 0, -2, -8, 0. And if we add these two rows together, we obtain, for a new second row, 0, -2, 2, -2, -2, and 0, leaving the first row unchanged. We can now repeat this argument for each of the other rows. For example, if we multiply the first row by a -4, we would obtain -4, -12, 0, -4, -16, and 0. And so adding term by term, we would have 0, -12, 12, -1, -12, and 0. Multiplying the first row by a -7 and adding it to the fourth row would yield, let's see, -7, -21, 0, -7, -28, and 0. So the sums become 0, -20, +20, -7, -20, and 0. Finally, if we scale the first row by a -3 to obtain -3, -9, 0, -3, -12, and 0, and add that to the final row, we obtain a new row of 0, -7, 7, -2, -7, and 0. Now in this new matrix, we have an awful lot of terms that lead with a negative values. So let's multiply every row through by a -1. That means we're going to have this matrix here. Also note that every element in the second row is a multiple of 2. So if we scale the second row by a half, we would obtain the following matrix. Now, let's use this pivot to produce zeros underneath it by the same argument. If we scale the second row by a -12, we would get -12, +12, -12, and -12, 0. If we scaled the second row by a -20, we would obtain -20, +20, -20, -20, 0. And if we scaled the second row by a -7, we would obtain -7, +7, -7, -7, and 0. And so if we add term by term, we would obtain the new matrix 1, 3, 0, 1, 4, 0 for the first row, 0, 1, -1, 1, 1, 0 for the second row, and now the third row would become 0, 0, -11. Oops, I missed an entry. 0, 0, 0, -11, 0, 0. The fourth row would become 0, 0, another 0, -13, 0, 0. And the final one would become 0, 0, 0, -5, 0, 0. Now notice that each one of these final rows can be scaled down by a value. If we scaled the third row by a -11th, we would obtain 0, 0, 1, 0, 0. If we scaled the fourth row by -1/13th, we would obtain this. Oops, I'm still missing those extra zeros. And the final row would be scaled down to this, leaving the other two rows unchanged. Now, working on the third column using, well, in the third column, we don't have a pivot position. So we'd go to the fourth column. Our new pivot is right here. We could use that to obtain zeros in the two rows underneath it by simply subtracting the third row from the other two. If we do that, we would obtain zeros in this entry and this entry. And now note that our pivots form that zigzag step, and so we are in row echelon form.